Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en ik zit zoals altijd met de enige echte
Jan Stomporst, Solutions Architect, ACC ICT.
Wat zeg je dat toch mooi, Jan?
Ik moet toch af en toe, weet je, wat veranderingen brengen.
Ja, het klinkt wel goed.
Dat er naar regen komt zonneschijn. Nee, ik heb net sneeuw gezien en regen en...
Ja, en een mooie talk heb je hier gezien op de SC Radio in Amsterdam natuurlijk, hè?
Ja, en waar gaat die over?
Nou, dat is een hele interessante. Containerless in Kubernetes.
Oh jee.
Nou, dat klinkt een beetje als vloek in de kerk, maar our guest Deepu will tell us everything about serverless and containers. Welcome, Deepu.
Yeah, thank you.
At first, can you introduce yourself to our listeners?
Deepu Sesidaran. I'm a developer advocate doctor. Also a polyglot developer, speaker, author, all the developer advocate stuff that you usually see. I predominantly work on the security space these days with interest in DevOps, languages, stuff like that.
Okay, and what's your background? How did you get started in the IT?
I started, I'm trying to think, 2010 in IT. So I started off as a software engineer working for a consultancy in India. I moved to Singapore working for some airlines, again as consultant, mostly developing JavaScript applications, web applications and stuff like that. I moved to Netherlands 7 years ago, working for a DevOps startup. Okay. We were building deployment, automation and orchestration tools. Then I also was doing a lot of open source back from that time. I think for last 10 years, I do a lot of open source. I am the co-chair of a project called JHipster. Now it's a rapid application development platform for Java, .NET and stuff like that. It's a pretty big project. I have been leading that project some time, and recently I moved on to co-chair and vice president of the organization kind of role. It's a non-profit thing. I also do other open source projects like K-Dash, which is a Kubernetes dashboard written in Rust, and few other open source projects. So I do have a lot of interest in open source languages. So I predominantly work with Rust these days, but I also do Java, Go, JavaScript, and few other languages.
Rust is the best?
So far, yeah. For now, I think I have done more than a dozen. I have worked in more than a dozen languages. I think I have worked with all the popular languages. And out of all those, Rust is my current favorite.
Yeah,
I would say, yeah.
Okay. So your talk was Go Containerless with Kubernetes in WebAssembly.
Yeah.
So can you tell us and our listeners what your talk was about?
WebAssembly has been around more than 5 years now. It was meant for the web, so it was meant as a performance option on the web, because there is a limit to what you can do with JavaScript, right, in terms of performance. Mm-hmm. So it was meant for that.
So it's for running a complete application in your web browser.
Yeah, so you can web browsers. Most web browsers has a WebAssembly runtime.
Mm-hmm.
So you can have a WebAssembly application, render it on web, and have it run faster, for example, than your traditional JavaScript application, right? So basically, WebAssembly on the web is used for heavyweight tasks, to offload heavyweight tasks from your normal web applications. For example, if you have a photo editor on the web, right? Doing it with JavaScript on the web is going to be tedious. It's going to have performance implications because you need to load a lot of things. You need to process a lot of things. The performance takes a hit, and at some point, these kind of big, heavy applications on the web will start to have performance issues. Mm-hmm. So that's where WebAssembly came into the picture. So all those kind of applications are being migrated to WebAssembly because it will be faster. So running a WebAssembly application on the web will be as equivalent of running a native application on your laptop.
Can it also use more memory than a Java application? Because in the web browser, you get a sandbox
So it uses the memory more efficiently. So,
But it's the same memory as a normal.
same memory. It's the same memory, but like a web browser doesn't have a limit on the memory, right? A web browser can still use as much as memory your system has.
For our users will know.
Yeah. So the difference is WebAssembly on the web is more efficient. So if let's say you have 500 megabytes of memory left on your system and you're running a photo editor on Chrome, right? That photo editor will run faster with the same memory if it is on WebAssembly than as a JavaScript application, because JavaScript is not efficient. It's the least efficient language out there compared to other languages, right? So JavaScript applications, though can be fancy, is still not going to be as efficient as a language written in Rust. I mean, application written in Rust, for example. So when you write something in Rust and compile it to WebAssembly, it's going to be extremely fast. And if you can run that same thing in a browser, it's going to be fast as well. So WebAssembly currently is being used for offloading purposes.
Okay.
And it has a great integration with JavaScript. So within the JavaScript application, you can, let's say you have a heavyweight task, you can call WebAssembly for that, get the result back, and still run the JavaScript application kind of thing. So it coexists, and that's how it is being used. I think a lot of photo editors and stuff are written in WebAssembly now. Figma, for example, I think is written in WebAssembly.
Okay.
So if you have like an extremely complex thing, and if you see it being really fast, there's a very high chance that it's WebAssembly.
Right. Can you see that? Probably you could see in the browser that you're running WebAssembly.
If you go into the developer console and if you start exploring, you will see that. But for a user,
Now for users, necessarily. Okay. So
the integration is great.
So you've got, if you go way back, you've got assembly as the language, the machine code. But it's only comparable in name, right? There's maybe the philosophy, or
I would say it is comparable in name, but also the core principle that it's a binary format, right? Assembly, assembly in the end is a binary format. WebAssembly in the end again is a binary format. So the binary format can be executed by any WebAssembly runtime. So it's a standard binary format, right? So as long as you build for the standard, any runtime which conforms to the standard can just run the binary. So browsers have inbuilt runtime for that. And with Vasi, we have these Wasm-Edge kind of runtimes that we can deploy in Kubernetes for that. And there are runtimes to do that the same in, let's say, Node.js or other environments as well.
Yeah. So what's the main advantage compared to a container running in Wasm?
So if you compare a container with a WebAssembly workload, let's say on Kubernetes or
right.
just a container, just as container where if you run it with Docker, for example. Kubernetes doesn't matter. Let's say we are running it on Docker. So a container is still a sequestered file system, right? It still needs that OS primitives, right?
Yeah.
It is much more lightweight.
There's libraries, yeah.
So the much more lightweight than a standard OS, but it still needs the bare minimum for it to work, like for example, the file system stuff, the networking stuff, everything in Linux is a file, right? So you need files for all that. So if you want to do curl within your application, that container should have the curl binary somewhere. You have to do, so every action, every execution your application needs to do, it has to find that file within the sequestered file system of a container. So though it is lighter than an actual VM and it's not a full-fledged OS, it still needs all the primitives. It still needs all the OS primitives. You still need to embed all the libraries that needed by the application, everything.
Yeah, you're kernel dependent also.
Yeah, exactly. So whatever is required for the kernel. So the basic kernel has to be there. All that things has to be there, right? Whereas in WebAssembly, it doesn't have that requirement, because in the end, it is just a binary that you need to build, and the runtime has all the required stuff. So the runtime has all the basic stuff like networking, file system access, all the basic stuff is there. So your binary just have to conform to the standard. So it is like building a native application for the operating system. So when you build a native application for the operating system, you don't embed anything. You just build the application and you pass it to the operating system. Operating system figures out how to run the application. Same way, WebAssembly binary, you pass it to the runtime figures out how to run it. You don't have to provide all the supported stuff there. The OS primitives you don't have to provide. So that makes it lighter in size as well. and execution speed, because when you start a container, you have to initialize the container, right? So initializing a container is basically unpacking it and putting the file system out there and starting up that mini OS, right? You don't have that step with this. So it can have near zero execution startup time. So it'll start extremely fast. And as I was mentioning in my talk, if let's say you have a batch job, right? If you package it as a container, and if you package it as a WebAssembly, and if you run them, let's say the actual thing, the job takes 2 milliseconds. So when you run it as a Docker container, it might take 3 milliseconds to finish, because it takes 1 milliseconds to initialize the container, then run 2 milliseconds. Whereas if you deploy it as a WebAssembly application, it will just take that 2 milliseconds and maybe like few nanoseconds of latency.
Yeah.
But that's going to be the difference in startup speed. And also, WebAssembly is supposed to be near native in terms of execution speed. So you cannot guarantee that with Docker containers.
Yeah.
The execution speed really depends on the application, what language it is written in. Like you cannot expect, let's say, a containered application written in Java to have and a containered application written in JavaScript to have the same performance. They will vary in performance. The language dependent things, but WebAssembly will not have that issue, because in the end it is compiled to a standard byte.
Yeah.
So regardless of the language that you have returning, if you have if you have written it in the same way, for example, without specifically introducing bottlenecks, it's going to be much faster. Comparatively, going to be faster than language dependent.
Yeah, and those milliseconds don't sound like much. But if you look at the broader scale and the large enterprises with starting up every single time, it can go up very quickly, all those milliseconds.
Yeah, and that is why WebAssembly is also a great option for serverless, true serverless, like
True serverless.
true serverless.
That's a new thing. Serverless. Trademark.
Because when we talk about let's say things like Lambda and these kind of serverless platforms, right? The expectation or the what we are sold is that, hey, you can have an application there. You don't have to run the application all the time. You can have the application. When you have a request, the application will start up, serve the request, and
Go down. Yeah.
So you only have to run the application when you have request. Otherwise, you don't have to spend the money on the CPU or whatever, right? That is the promise. But do we actually have that? No, right? Because anyone who has run that kind of setup will know that when you do the first request, there is a warm time, right? It has to start. Then you serve the request, and if it dies before the next request comes in, then again it has to do the start. So the first request always is delayed. Subsequent, if continuously get requests, that should be fine. It will be fast. But the first request always has that startup delay, right? But if it is a WebAssembly thing, that startup delay is going to be very minuscule. That's why it says like near zero startup time, right? So it's not going to be zero, but it's going to be very minuscule compared to a traditional serverless workload. So with WebAssembly and the right kind of application, we can have that near startup speed, and we can truly have something that only runs when a request comes in. It doesn't have to be kept alive, because most serverless workloads in the end is kept alive, so that requests can be served faster. You don't have to do that kind of stuff with WebAssembly.
Okay. And go ahead.
And can you put every application in WebAssembly?
Yes and no. So yes,
It depends, Rohan. It always depends on the workloads. Yeah.
yes, because WebAssembly is flexible. Most languages supports it, so you can compile from any language. But since the WebAssembly runtime is also much more restricted compared to a normal operating system, you can't just take any application and simply compile it to WebAssembly like how you Dockerize an application. We can basically take most applications and just write a Docker file, and it becomes a Dockerized application. You don't have to do much in most cases for that. But it's the opposite for WebAssembly. In most cases, you would have to do a lot to make it compile for WebAssembly, because let's say let's take an example. So I have this application called Kdash, right? That renders a nice UI for Kubernetes. It's in Rust, the great language for WebAssembly. But if I take that application and if I try to compile it for WASM 32 WASI architecture, it will fail. it will fail with a hell lot of errors. And if I start going through the error, I will see that this particular library doesn't work because I use multi-threading. WebAssembly doesn't support multi-threading, so I cannot use multi-threading on my application. WebAssembly,
That's a big thing. It's not supporting multi-threading.
not yet. It is being standardized. So there are lots. So WebAssembly has been around for a while. WebAssembly on the web is a bit quite mature. It's quite good. It has a lot of features. But WebAssembly on operating system, like with WASI, is much like new.
So you've got two things. You've got the one that runs in the browser.
That's like just
That's normal, and you've got WASI, and that's a WebAssembly on your system,
yeah. So
and it runs on Mac,
yeah,
Linux, and Windows.
Yeah. So WASI is like a bridge that makes it possible to run a standard WebAssembly application binary on an operating system.
And that has not multi-threading in it yet.
So the WASI standard has some limitations as multi-threading is still being standardized, not like completely standardized. It's being worked, I think, in a stage 3 or something like that. I think it has a 5-stage evolution process for features. Networking, HTTP is fine. HTTPS is still not standardized. So doing TLS on a WebAssembly workload is tricky. Network isolation is not standardized, so it is still a bit problematic. Resource isolation is still being standardized. So there are a lot of things that are still not standardized when it comes to WASI. That's why I keep saying it's still evolving, still not mature for a lot of standard use cases. So compiling anything to WebAssembly is still not a distant. You can in the end, but you will have to do a lot more work. Like you would have to rewrite your application in some parts. Probably you would have to switch libraries to something that supports. For example, in the Rust ecosystem, if I want to use a library, on WebAssembly, I would have to search for the library with the WASM support. Most libraries will have a different version with WASM support.
All right.
Might have removed some features or added more code to make it work with WASM and stuff.
Okay, so for now, if you want to get started with it, use the browser.
For pure WebAssembly, browser only is fine. But WebAssembly on Kubernetes or Docker, you need WASI, and for that, you would have to keep these.
Yeah, so it's not interchangeable also, no, not yet.
The same binary can run. As long as the binary is WASI compliant. So
yeah, of course.
With some
yeah.
WASI, it can run on the browser.
Yeah.
Okay, but vice versa, probably not.
Kost het beheer van Kubernetes je veel tijd en expertise? Maak kennis met ACC ICT. Zij ontzorgen je volledig met managed Kubernetes diensten op elke cloud. Gecertificeerde specialisten zorgen voor compleet beheer, 24/7 support en optimale beveiliging. Jij kunt je focussen op je core business, terwijl je Kubernetes-omgeving in betrouwbare handen is. Manage Kubernetes van ACC ICT. Jouw zorg, onze expertise. Bezoek accict.com.
And you said WebAssembly has linear memory.
Yeah.
But what if I have a Java application and I put that in WebAssembly? Java uses a heap, and there's the heap again. It uses a heap, and that's not linear. How does that?
That's why you cannot take a Java application and make it WebAssembly using JVM. You cannot do it with JVM. You need to use a specific VM called TVM, which supports linear memory model. So if you take a Java application and compile it with TVM, TEE, chai, right? TVM, you can make it WASI compliant, but TVM
comes with limitations. All great power has some limitations.
I mean, it's that's the way how new things work, right? It is still not the adoption has to be there.
Exactly, and
I would say like a couple more years for it to. I think things are so. A couple years ago, when I started with this topic, there was no networking support at all. So I cannot build a WASI thing with any outgoing networking or incoming networking at all. So I cannot run a web server like the demo I did today on WASI like a couple of years ago. But today I can do that. So now the only restriction is TLS, but that is being standardized. So I would say in the next 1 year, these things will be standardized. File system will be standardized. Networking will be standardized. So you can do like all networking stuff without limitations then. And like, let's say a couple more years, more things will be standardized, and then the limitations will go.
It's same for Kubernetes, right? Version 1.0 was nothing like what
was
was
great.
But
That was so awesome. But yeah, so Java is a bit of a problem. But when we run a WebAssembly in Kubernetes, you said the resources are not standardized yet. So I can't set
isolation.
resource isolation. So what is that? Resource isolation. So my applications can see each other?
No. So, I mean, it will still have its sandbox and everything.
Yeah.
But if you're accessing file system stuff, the isolation to make sure that you can only access a certain file system, not others, those kind of stuff is a bit tricky. You can do those kind of things, but it being not standardized means every WASM runtime will do it differently.
Okay.
So so there
You've got more than one runtime.
Yeah, there are multiple, like WASM Edge is one, then you have Spin, you have WASM, or you have many runtimes, and all these features which are not standardized, all of them, they do it as they like. And of course, like once they are standardized, I'm pretty sure they will move towards that. But for the time being, it's depending on which runtime you choose. They might do it differently.
And just for my interpretation, do browsers use also a different runtime, or do you give the runtime with your WASM applicatie?
So browsers has inbuilt support for WASM, not WASI. So for WASM,
Okay.
so the WASM runtimes, I think they are pretty standard. They don't have these standardization problems. It's only for
WASI.
Yeah, only for WASI we have this standard, because WASI is newer compared to WASM. WASI is an afterthought, I would say, because WASM was never meant for this purpose. WASM was meant for a browser only. I think nobody even thought you could use that for these kind of purposes back then, probably, because the requirement was just for browser, so everything was done for the browser. Then like suddenly, hey, you can do this outside the browser with the same benefits, right? Why not do it? So then WASI came into the picture.
And is WASI, if you think about the browser, is WASI some kind of browser then?
No, WASI is just
I was thinking
spec. It is an interface specification.
If it runs WASM, it should be a bit of a browser.
Not really. Like the WASM runtime within Chrome, for example, is just a part of Chrome. It's just a small a runtime within Chrome which can execute, which can read the WASM binary and execute it, right? So WASI is an interface specification which says how to run WASM binary on an operating system primitive. So it's a specification. So the runtime, so WASM Edge, for example, have to implement this WASI specification for it to be able to run this binary on an operating system. And that is where when things are not standardized in the specification, then they tend to do it however they like.
Yeah, of course.
Yeah. So how would you deploy WASM in a Kubernetes cluster?
Multiple ways to do that. So I showed 3 ways to do that today. So the WASM support or WASM WASI. When we say WASM in Kubernetes, it's always WASM WASI, right? Because you can't just do WASM in Kubernetes.
Okay, sure. Yeah.
So it's always WASM WASI. So WASM support in Kubernetes is widespread now, I would say. Most CRI runtimes support it. So I think all CRI runtimes, except maybe some niche ones, they support WASM. Like Containerd, Portman, Docker, they all support it. OCI runtimes, Cron and Yuki supports WASM out of the box. The others don't. Others you would have to specifically build it with WASM support if you need and stuff like that. But the most popular ones, they do support. And all the OCI registries support WASM. Like WASM
Or some images.
And most Kubernetes distributions support it. So the ecosystem has great support. So we can do it in multiple ways. What the simplest would be, take a WASM application, put it in a container.
Oh no!
But it is still, let me see. It means put it in a container and run it like a normal container.
Yeah, but that's containerless.
It is not containerless. Because you still have a container, but it is still you're still going to get benefits of that WASM being faster. The application is going to be faster. It needs much less OS primitives and so just needs the WASM Edge binary there. You don't need all other OS directly. So it is a
Serverless container.
Serverless container. Yeah.
yeah, can be that. So it is going to be a much lighter option, but it's the easiest option. But it's not the recommended option, it's just the easiest option. Then we have two more better options. The next option is to use CRA runtime, like Containerd, for example, that supports WASM, and say CRUN on the OCA runtime that supports WASM. So Containerd has a shim for this, like a WASM shim. So when you have a WASM workload, so then you can directly deploy a WASM workload without a container, and Containerd will figure out, okay, this is a WASM workload, and it will tell the OCA to run it as a WASM workload, but it is still being run by a OCA.
Yeah. So there's something in between, but it knows where to go.
The execution path is a bit
Still there. Yeah.
No, it is still not a container because they are not deploying a container. It is being run by a OCA runtime, which will have WASM edge in it.
Yeah.
So CRUN will have WASM edge in it.
Okay. Yeah.
And it will run this through WASM edge, but it is still going through Containerd.
Yeah. So every request has to go through that.
Yeah. So it is like going through three points to run it, right? It is better than, it is still going to be start fast. It's still going to start faster, run faster, use less memory than a container. But we have a better option. So the best option would be to use, so Containerd has another project called Runvasi. It's another shim. So if you use Containerd with that shim, then it looks at your workload, and if it sees that this is a WASM workload, then it skips OCA and directly executes it with the WASM run, like WASM edge, for example. So that's the best option because it has the least, the shortest path of execution. It's going to be the fastest option. So it will give you all the benefits of running a WASM image. We are so used to say container, right? Right, it's the best option. But that means you'd also have to add WASM edge into your distribution, which is quite easy. I mean, for example, we have a project called KWASM, which provides everything required to add WASM edge onto or spin onto your distribution. So you basically you run the Helm chart and it adds WASM edge support to your distribution, and then you can start deploying WASM.
Okay. Well, I can also see use case for AI workloads, I think.
So the AI, again, it's a feature that is being standardized. So like LLM support is coming to WASM, still not standardized. But it is a good use case for faster things because running those can be, you need better latency and memory efficiency and stuff.
Yeah.
So that's coming.
Okay.
Currently, I would say the most used, it's being used a lot. For example, there is this entire thing that the Spin and all these companies, there are entire companies around this now, which is providing platforms for microservices and all these stuff, purely awesome stuff, right? Most of these are edge kind of things, edge servers and these kind of things. So those are also great use cases right now. So where latency is extremely important for you. So if you have application or use case where the latency startup time is like critical, then this is a great option because you will never achieve this kind of latency and startup speed with a Docker or anything else.
Is it the latency? You said, what if I run not a Docker, just a native application? What if I run Rust native on a machine? That's faster than WebAssembly.
On your PC.
Yeah?
Yeah. If you run a native Rust application on your PC, of course, it's going to be slightly faster than a WebAssembly application running on the PC. But
why should I then run WebAssembly on my machine instead of native? So if it's not running in Kubernetes, it could do Kubernetes. You do fancy shit with load balancing and all of that stuff.
So on your PC, you don't. You that's not a target use case for WebAssembly. Running directly on the PC is not a target use. So target use cases are browser, of course, platforms like Kubernetes, edge servers. So on the server, you don't do it on the PC.
No, of course. Yeah. But also on the server, if I run Rust on my server, it's going to be faster.
Yeah, it's going to be faster, but it is not going to be as portable as this, right? The people offering this as server stuff are also providing the promise that you can, as long as you give it to us as WebAssembly, we can run it. It doesn't matter how you build it. You can build it in Rust, you can build it in Java, you can build it in Python. it's up to you. You provide it as this binary, we can run it. That's the problem. So it's about the standard, right? Because otherwise, then you'd have to say, hey, I can only run Rust application. That's not as portable. So this is much more portable. And also, another thing is things that are built for, let's say, a lot of projects have applications that can be used on the browser and also as native applications. So that's a great use case for WebAssembly. So if you build it as WebAssembly, you can run it natively and also on the browser.
The Electron app.
Much better than her.
But this Electron gives you the same things, but it's a browser in an application.
And Electron is still JavaScript and so it comes with all the bottlenecks and all the. So actually, there is for example, VS Code is an Electron application. VS Code is nice, but it is
slow.
There is another WebAssembly based editor, which is much more faster and starts much more faster, and you can run it on both web and on the client. So in the end, it is always about the better performance and better
Portability, performance portability,
Just scalability, probably. Or?
No, not that, because scalability you will do with Kubernetes.
Yeah,
Okay.
it's not
That's right. Yeah.
So it's portability and then speed on portability.
yeah.
Awesome.
So, our final question is also always, how do you see the future? Now, I can predict a little bit according to your story what do you want to see in the future, but take us on the journey of WebAssembly in the near future.
So I have been watching the space for a while now, and I see more and more things coming. Like, for example, support on the ecosystem, Kubernetes perspective. Support on the Kubernetes ecosystem has greatly improved. When I started looking into this, for example, Docker didn't support, Docker registry didn't support WebAssembly images. Now it does, for example. So most popular registries support WebAssembly images now. Most distributions support WebAssembly now. So it has been evolving. So the support has been evolving. The adoption hasn't been that great, I would say, on the Kubernetes side of things, because I think maybe because people are also figuring, if I can have all this advantage without Kubernetes also. So most platforms like Spin, for example, is offering this without having to need Kubernetes. So you can just deploy it on their cloud, for example, or directly. They orchestrate it and they do everything. You don't need Kubernetes for that. So WebAssembly has great adoption on serverless side of things. I think most cloud providers are internally using WebAssembly for things that needs like low latency and like extremely like fast startup time and stuff. They are using WebAssembly. And on the Kubernetes side, the uptake hasn't been that great because I would say there is a barrier of entry, and that you can't just take anything and make it a container and deploy to. You would have to rewrite, probably you'd have to start from scratch. So the only things that are using this are applications that are being written from scratch. Mm-hmm. Also, these features not being standardized is a blocker, right? Networking, the basic things, right? Like networking and file system has to be standardized. So I think once those are standardized, I would say like maybe within the next year, I am hoping that there will be more update, because then you don't have this issue of basic stuff like networking and file system being a bit uncertain. So I think that will drive more adoption, especially for applications that are new, applications that have high requirement of like low latency requirements and like startup speed requirements. Low applications that has to run in low resources is a great option. For example, if you are writing an application for WebAssembly in Rust, it's going to be a tiny application that can run instantly, use very less memory, and be extremely performant, right? Same if you're writing in C++ or something and deploy it on Kubernetes or whatever, it's going to be really high performing. So microservices and those kind of stuff, low latency requirements will see an uptake once these are standardized. But it has been growing. The support has been growing. There are a lot more tooling now, a lot more products out there. Companies has been like, there are a couple companies around WebAssembly now. Fermion is a big name there. Few other companies that are providing WebAssembly as an option. I think most cloud providers also now provide WebAssembly as an option on their edge servers. You can run WebAssembly workloads directly on like.
So WebAssembly is gonna conquers all?
I wouldn't say that because, in our industry, nothing goes away, right? If the legacy is the biggest thing in our industry, right? Like there are still applications that is running in WebLogic and stuff. So I don't see Docker going away anytime soon. So, and also Docker is easy and most applications don't have these kind of low latency, high performance requirements. Most are okay with the Docker level performance. So I think those will continue to be there. And I would say WebAssembly is still going to be a niche for a while, unless all these are standardized and like
you got to go fast. So
Go fast or go home. So thank you very much for your
insights.
Yeah.
An interesting talk. And we would love to follow this up in the future and see where WebAssembly stands in that point in the time. So,
thank you very much.
Yeah, thank you for having me. It was nice.
Deze podcast is een initiatief van ACC ICT en wij zijn te beluisteren op onze website k8spodcast.nl via Spotify, Apple en alle andere favoriete podcastproviders.